So what we're going to be doing today is we're going to be multiplying matrices. Now the first thing that you need to know is that matrices do not follow the commutative property. A times B is not the same as B times A. Another thing you need to be aware of is that we do label matrices with capital letters. That is a notation that is math standard. So before trying to multiply, you need to first determine whether or not the product is defined. In order to determine whether the product is defined, you need to look at the dimensions of the matrices. If you are doing A times B, in order for the product to be defined, these numbers must be the same. That will result in a matrix, we're going to call it matrix C, that would have dimensions M by Q. So here I have two sample matrices. I have matrix A and I have matrix B. First we're going to look at B times A. B has dimensions 2 by 2. A has dimensions 3 by 2. These are not the same value, so this is not possible. However, if I look at matrix A times matrix B, matrix A is a 3 by 2. Matrix B is a 2 by 2. This is possible, and the resulting matrix is going to be a 3 by 2. So now that we know that it's possible, let's actually multiply this matrix. So A times B. The easiest way to do this is to just space it out. Instead of giving you alphabet soup, I'm going to give you a number example. So matrix A is 6, 2, negative 1, 3, 0, negative 4. Matrix B, you'll notice I left some space up here. That's where I'm going to be putting matrix B. That's going to be negative 1, 5, and space over 2, negative 2. Now, why am I leaving this huge space? Because it makes everything line up better. Back when you were first learning your multiplication tables, one of the things that you would do is you would have 1 times 1, and you would put them together, and it's 1, 2 times 1 is 2, that kind of thing. We're doing something very similar with matrices. To get the element that goes right here, we're going to have 6 times negative 1 plus 2 times 5. To get the element that goes right here, we're going to have negative 1 times negative 1. Plus 3 times 5. To get the final element that goes down here, we're going to have 0 times negative 1 and negative 4 times 5. Now, reason of the gap. You see how this bleeds over? If I had this immediately close, then when I started doing my next row of multiplication, I would end up cutting into these. So by leaving that gap, I have space to work across. So 6 times 2 is 12. 2 times negative 2 is negative 4. 2 times negative 1 is negative 2. And then I've got 3 times negative 2, which is a negative 6. 0 times 2, which is 0, a negative 2 times a negative 4, which is a positive 8. So now we simplify everything. I've got negative 6 plus 10, so that's going to be a 4. I've got 1 plus 15, that's going to be 16. 0 minus 20, so that's going to be negative 20. And then I've got 8, negative 8, and 8. This is the resultant matrix. That is what A times B is equal to. And we got that from just literally following our fingers and getting the elements that way. So let's try some more, and let's look at the distribution property for matrices. So I'm going to set up 3 separate matrices. Matrix A is going to be 4, negative 3, negative 1, 2. Matrix B is going to be 1, 7, negative 4, negative 2. And matrix C is going to be 3, negative 5, negative 2, 1, 0, 6. So A and B are both 2 by 2 matrices. I could multiply them in any order, and so that's what I'm going to do. I'm going to first multiply A times B, and then I'm going to multiply B times A. So A times B, I've got 4, negative 3, negative 1, 2. Matrix B is 1, 7, negative 4, negative 2. And I did not leave a space, so I'm going to leave a space. So, to get our resultant matrix, we're just going to follow our fingers. 1 times 4 is 4. Negative 4 times negative 3 is a positive 12. 1 times negative 1 is negative 1. Negative 4 times 2 is negative 8. 4 times 7 is 28. 3 times, well, negative 3 times negative 2 is a positive 6. 7 times negative 1 is negative 7. And negative 2 times 2 is a negative 4. At this point, all we do is simplify. And we're going to get that the resultant matrix is 16, negative 9, 34, and negative 11. Okay, that looks pretty straightforward. Now I'm going to do B times A. So what that does is that's going to put B down here at the bottom. So that's going to be 1, 7, negative 4, negative 2, and now I'm going to space out my A. I've got 4, negative 1, negative 3, 2. So here, if I follow my finger, I'm going to have 1 times 4, which is 4, 7 times negative 1, which is negative 7, negative 4 times 4, which is negative 16, negative 1 times negative 2, so that's a positive 2, negative 3 times 1, which is a negative 3, 2 times 7, which is 14, negative 3 times negative 4, which is a positive 12, and 2 times negative 2, which is a negative 4. So that is going to simplify to negative 3, negative 14, 11, and 8. These are nowhere close to the same value. So you can see that the commutative property does not work. It does not hold for matrices. Why? Because of the order in which we multiply and because it has that combination effect. So what about the distribution property? So I'm going to leave those parked right there. And we're going to look at the distribution property. What if I had A plus B times C? How is that going to work? So, now, distribution property for matrices. And here, guys, order is important. It is not like the points on whose line is it anyway. Order is important. This is going to be AC plus BC. You'll notice that C here is on the right, and here when we multiply it through, it stays on the right. Order is important. So if I wanted to add matrix A plus matrix B, what I'm going to do is I'm going to add each element. This was our last section. So the first element is going to be 4 plus 1. That's going to give me 5. My second element is negative 3 plus 7. That gives me 4. I've got negative 1 and negative 4. So that gives me negative 5. And I've got 2 and negative 2. So that gives me 0. So that's A plus B. So now I'm going to take that A plus B and I'm going to multiply it by C. So I've got 5, negative 5, 4, 0. I'm going to multiply it by C, which is going to be 3, 1, negative 5, 0, negative 2, 6. Again, I've spaced it to allow myself plenty of room for the equations to expand out as I go. So this is going to give me 3 times 5, which is 15, plus 4 times 1, which is 4. 3 times negative 5, which is negative 15. 1 times 0 is 0. And I get negative 25 plus 0. 25 plus 0. I'm going to get negative 10 plus 6 times 4 is 24. And here I'm going to get positive 10 plus 0. If I simplify that down, that tells me that A plus B times C is going to give me 19, negative 15, negative 25, positive 25, 14, and 10. I cannot stress enough the importance of space and organization. Space and organization. If you are not organized and writing things vertically, you will get lost in the chaos. I cannot stress that enough. You have to be organized when you're doing this. Now if I look at the other way and I say, okay, A times C, if I multiply those matrices out, A times C and B times C, and I add them together, here's what happens. A times C, B times C. If I add them together, excuse me, I get this, which was the exact same as what we just found. So the distribution property does indeed hold for matrices.